20 seconds out, folks. Advent of code will be starting in 20 seconds. We got day 17 all ready to go, and for some reason, my co-pilot has decided to abandon me, so we're going to be doing that without co-pilot, but I'm sure that's only going to make it easier, of course. And here we go. Again, thanks for coming by, everyone. Rocks. We love rocks. Rock and roll. Oh, this is another sand simulator, it looks like. Okay, we can do it. Paste it in. There we go. Let's... Okay, clock is failing. That's okay. We'll figure this out. Okay, the 5 types of rocks have particular shapes. Oh, this is Tetris. Oh, Lord. That's not my input. Suppose this was a jet pattern. Wait, what is input? Yeah, this is my input. I'm goofed. There's my input. Oh, it's types of wind. I think I understand this. Okay, here we go. Let's figure this out. First, jet of gas pushes rock right. Rock falls. Pushes right. Falls. Right. Falls. Falls. Left. Falls. Great. So left. Okay, it only goes left by 1. Right. Okay, I think I understand this logic pretty well. It's Tetris, I understand that. We're going to be doing flipping part 2, I bet. Supposed to calculate the height. Are these walls or are these something? These do appear to be walls. Okay, okay, okay. Got it, got it, got it. Okay, so let's figure this out. Const rocks equals. I guess we're going to do an array of this. I'm not sure the format I'm going for. But we'll do an array of rocks, which are matrices. What are the dots? Dots are empty space. Great. So now this one is another array. Hey, appreciate you coming on by. What, and Madeline. You both doing well? Hey, Ryan. Thanks, you too. Hello, hello. We're playing Tetris apparently. That's fun. So this is not an array of just that. It's an array of um empty pound empty. I don't know how I'm doing this some way. Eh. Rock and rolls. Yes, I did, Madeline. I was there. Looking forward to the Monster Monday. Sorry to hear that, Ryan. Yeah, basically, next week is where a lot of stuff kind of picking back up. Gonna have announcements Monday, the agency, all that stuff. Should get more news there. Wave 1 rollout, along with streams Tuesday and Thursday. Sponsor one being Tuesday. For sure, yeah. And apparently Monday is also when Wave 2 will open up. Or they'll be ready for submissions for Wave 2. This is horrible formatting. We need another one. And these are rectangles, so that's going to be fun for future me. Yeah. Straight up on his tooth on that one, Madeline, yep. You just gotta disconnect, unfortunately. Mm-hmm. Arrays of strings. Yeah, that works. Okay, falls in the order shown above. First, the great, 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 great. Okay, so it's a rotating thing. Don't spin, but get pushed around. Okay, and this is the jet in my K. We got jets, folks. Woo! So this goes after every step, 7 units wide. Ooh, tough one. Okay. They drop in the center. Let's look at the other one. Where does it start falling, though? Push to the left, push to the right. Each rock appears at the left edge is 2 units away from the left wall, and its bottom edge is 3 units above the highest rock in the room. Okay, interesting. 3 above highest X. Okay, we'll have to do how many rounds of this, right? 4, let r equal 0, r less than equal to 2023. Probably off by 1, but that's alright. So those are all of our lovely wounds. We're just going to say let rx equal let rock, let ri equal 0, rock equals null. If not rock, congratulations, rock, you just became an object. You are taking a screenshot. Sorry about that, folks. You are shape rocks ri plus plus, right? And then I guess we're gonna do some logic in here. Make sure ri rolls around. Not the rock, the index. If ri greater than or equal to rock's length. Congratulations, ri, you're back to 0. Beautiful. We want some other information too. Where is, I guess this is, I guess it doesn't really matter. Wait, what is it I'm looking for? How many units tall will the tower be? I have to kind of design my own thing, don't I? Okay, so if no rock, let y. So, okay, so I gotta figure this out myself. Yeah, so it starts, where's the left edge is 2 units away from the wall, bottom edge is 3. Okay, so I guess I'm gonna call this one, okay, we'll do row equals, dang it, all these letters, round, congratulations, okay, let highest row equals number 4. That's gonna be tough to do. I mean, it will be a matrix, so I guess I'll make a world. Const world equals new map. Congratulations, world. We're gonna say let highest row point in world equals 0. Then we're gonna say for const key of world dot keys. Then we're gonna say, hey, great. Okay, so const rc equals key dot split by this. If r greater than highest point in world equals r. Congratulations, we love you for that. So now your r is going to be highest point in world minus 3, right? So right now it's going to be 0, and you start off at 0 plus 3? Plus 3. Quick maths. 0, 1, 2, 3. Great, I got that part. Now your left is going to be your column. So I guess C will always be 0, 1, 2. What does the other one look like? 0, 1, 2. Yeah, C is always 2. Congratulations. Okay, so that initializes our lovely rock. Big fan of rock. Rocky the awesome rock. Now we need to begin our simulation. So first rock, jet of gas pushes right. Okay, I can understand that. I'll have to do bounds detection and all that. Funnest of fun stuff. I guess we can do const jets, or jets equals data dot split into a lovely array. So I can just say const jet equals jets pop if jet, because I guess we might run out of some eventually. We're gonna say try pushing stuff around. We have two possibles, left and right. Okay, if jet triple equals left and rock.c triple equals 0. Continue, you're done. Okay, I guess I should put this logic inside here to handle the other case. Drop that there, else, rock.c minus minus. Congratulations, rock is a moving. Else, if jet triple equals greater than, because I think part 2 might have different wind patterns up and down. Const, okay, we also need to get a width for the U. Width of shape is 0 dot length. Okay, I can get a width. Const width equals rock dot shape 0 dot length. I'll put this in a variable. We like easy accessibility. Const shape equals hello shape. Congratulations. Width equals shape. I know how to spell the word width. Equals shape 0 dot length. Congratulations. Again, this is another one that visualization will help with debugging. If rock dot c plus width greater than or equal to, or rock dot width. Now we got to do quick math. Okay, so c is 0, 1, 2. 2 plus 4 is 6, is not equal to 7. Here it's 0, 1, 2, 3. 3 plus 4 is 7. It fails. Don't go anymore. Great. Greater than or equal to 7. Continue. I'm really making these a little painful because my inverses are like this, but it works. Rock.c. Now finally, once we get to the end, I guess this is where we do rock.r, negative, negative. If not rock.r, ooh, or collision. That's the fun part. So this is technically, I think I only need to care about this. What happens if I'm going down and I like take a left to smush into something, huh? You need some collision detection there. Like, yeah, so for every movement, it's not just up, down. So I got the bounds. I just now need to not hit things. Rock dot, if not rock dot r, that's technically not really how it works. I mean, this still the initial one will work. If not rock r, rock equals no. Make new rock. Great. Now for all the world collision detection. Okay, if rock c continue, plus new points equals, here we go. So it's going to be depending on the shape. Okay, I can get that. So that'll be for const row, or rr row of rock dot shape. No, not like that. If will be for const cc no, cc no, cc car of row. If car, well, if not car, toodaloo. There we go. And now we're gonna have well, continue. I'm missing something. There, that's what I'm missing. Otherwise, we're gonna say new points. Whoa, new points. Dot push, and our new r and our new c. So it is rock dot r plus rr rock dot c plus cc. So I'm trying to think if I've done this correctly, because this is 0, 1, and 2. Firstly, our row is reversed because we're doing a negative decrement. Our column, though, 0, 1, and 2. Yeah, tic-tac-toe. Congratulations. There we go. We're winning. This will be correct of our new positions. So our row would need to invert it. So instead of rock minus RR, that doesn't feel right. But minus is working for the rest of it. So maybe rock minus RR. What have I done wrong? Oop, forgot my dot entries. This is just what I was telling people about. It's the dot entries magic. Thank you. Okay, so now we're gonna check if any points. Whoa. New points dot sum point world dot has, and then cute string. Something to easily for ease. RC has R comma C. Basically, if any of them exist, then don't do that. Here's the thing, I can't track myself. So as I live, I have to pull myself out of the world. So these are currently my points, actually. These aren't new points. These are my points. My points. Coordinates. There we go. For your coordinate, yeah, go ahead and push all the things out. And while you're at it, world.delete. Technically, I don't need to do this because it's once I stop moving, my coordinates into the world. So, okay, I don't need that there. New points, So if I'm decreasing C, it'll be const new points equals all old points. Then RC, it's going to be RC minus 1. And there we go. So if it's in the world somewhere, I can't fly that way. Great. Same logic for the row. Or the other direction of the column. Plus 1. Awesome. Now here's the fun part. I guess we gotta do new points again. New points again are minus 1. Here's the thing. Once we're moving down, if we land on something, like, can we move when we've landed? Falls 1 unit, goes left, falls 1 unit, comes to rest. Oh, that don't make visual sense. Check the next one. So you land, go right, falls 1 unit. Okay, so it's the falling that has the collision that solidifies it. Okay, fun. We have our new points, which is lovely there. If any of them are already on the world, then I solidify the rock. If the rock is not the rock, then I solidify the rock. If I'm moving left, I ignore. Move right, I ignore. I don't think I have these in the correct order, but I suppose our visualization will tell us that soon enough. So here for these two, I need to solidify rock. So solidify equals true. Congratulations. Else, you're gonna move the rock. Then here we're gonna say rock.solidify is true. Yeah, we know rock don't have this. Solidify, we'll initialize it to false. Loving that. Now here, rock.solidify, then for all your points, you're gonna go into the world. So we're gonna recalculate your new coordinates. I guess we can just clear them out, but we're doing it again. And yeah, because we don't actually need to do this. Yeah, rock R, rock C. Beautiful. So it's going to be world dot put, well, set, and then rock dot R. Oh no. Rock dot C, closing. And I guess we'll put you as little hashtags. BEA beautiful. R plus RR or minus RR. C plus CC. Should do the trick. I forget how high this is. Rock falls 1 unit. Yes, how many do we supposed to do here? They want to know how tall the tower will get after 2022 rocks have stopped. Oh, okay, I'm not counting rounds, I'm counting rocks. Okay, so let rock stopped equals 0. There you go. So this is not a for loop, this is a while loop. Oh, where's my while loop? Rock stopped that length, or it's not length, less than or equal to before, yeah, so 2022. Congratulations. And then whenever we do stop a rock, we do this. Ta-da! Okay, this is the fun part. Now I have to return the highest rock, which I calculated way up here. Apparently I didn't need the roll. Now this ain't gonna work, of course. Why not? You can already see this literally is never happening, so I'm guessing they're not getting placed in the world or something like that. Interesting. This is definitely gonna be a fun one to visualize whenever that happens. For key of world keys, world's a map. Create our new rock. We're doing this. Okay, you might need to log or debug this. We can start by continue. Yeah, that does do what I want. So I guess here's what I want to look at the rock. Show me the rock. Yeah, good rock. Okay, so row 3, row 2, row 2, row 1, row 0, row 0, row 0. You stay at row 0. Very sad for you. So what happens every time? My simulation loop is off. First rock begins falling. 0, 1, 2, 3, right? Jet pushes right, then fall. Right? Fall. Oh, right? Fall. Left, fall. Okay, that part is correct. I guess I only want to go through the first 10 or so. And let's see what this is now. So 3, 2. Yeah, so we start off with 2. We get pushed to the right. 2, 1. Get pushed to the left. Wait a minute. C is 2. We go right. We go left. And where do we end up? Yeah, so originally we're here. We end up right back where we started. Okay, so that is correct. It's when the rock lands, it does solidify, true. I never flip it off. There we go. Rock equals no more rock. Rock on. There you go. Now that's getting ran. Okay, so after 10 rounds, I might need a ask diagram. We're gonna trust I did it right. 9. Yeah, that's not what we wanted. Okay, this might be a bit of a big one, but I mean, it's rock simulation. It's not that hard. Surely it's not that hard. Famous last words. It's already taking a while. It could be running on the real one. That could be what's up. So this should not take. Oh, what happens when I run out of wind? Do I loop? If the end it repeats. Whoops a daisy. Yep. Okay. So I gotta fix that. Jets equals j split. Let ji equals 0. Same logic for jets. Const jet equals jets ji plus plus. Where's my logic? Right there it is. So instead of ri, it's now ji. Instead of rocks, it's jets. And well, I did it again. It's ji. Okay, that should be working there. Now we have big number. That's the wrong number. Very sad. 999. What an interesting number to stop at. Let's hit a plus on that, I suppose. Okay, you want to be weird on me, or don't render. 999, is that equal to this one? This is where the visualization would be awfully handy now, but I don't have that. I could visualize it. Okay, we can start visualizing it. So, function viz, we have the world, we have the rock. We have enough information to visualize it. Here we go. So, we still need the highest point, which still isn't the hardest thing to calculate. Highest point in the world right there. 3, 4, let r equals highest point in the world, r greater than or equal to 0. I am wrong way. Greater than or equal to 0. R minus. This really should be called height, but it's too late. Or let c equals 0, c less than or equal to 7. That's technically, hold on. 0, 1, 2, 3, 4, 5, 6. Yeah, less than 7, c plus plus. There we go. It's gonna be if this is gonna be the line, I guess. Let line equals pretty line. If world dot, it would be adding to line. A line plus equal world. Nope. If world dot has, and then make the cool string. Inside the thing separated back gammas. RC, then it'll be line plus equal world dot get, and then I gotta rebuild that string. We love that. Then I need to build the coordinates for the rock. Where is that? Coordinates, there we go. And then I do have access to rock. Yep, right there. I suppose this is going to be if rock. So it could be in the middle of the fiddle. There we go. So if rock, okay, you're cool. You can figure that out. TypeScript. You're an any. Get over it. Thank you, TypeScript, very much. Rock arm, ICC. Okay, I think I got that math correctly. If I don't, we're gonna see it right now. If world has it, then we'll draw it. If coordinates sun RC RR or R RC, and then it's gonna be R triple equals RR and C triple equals CC. Basically, if you found one, or RC, I guess. And then you're gonna add to line plus equals an ampersand. Finally, I guess this will be output. Let output equals love this string. I know how to spell the word output. Output plus equals new line plus line. Congratulations, and then I guess it'll be console log, and then it'll be a lot of those. Console log, and then finally our output. Now this is gonna run a lot, so we're gonna limit it to 5. Would be helpful if I called the function, would it not? Probably would be. I guess technically we want to visualize before. Where do we want to visualize? Gotta just do somewhere, I suppose. Okay, this looks very awesome. So we're not adding the empty spaces. Oh, whoops-a-daisy. So it's this, else if, and then finally else line plus equal space. So we're not going to see the right border, unfortunately. Oh, we can do that. Line is plus output, and then finally that's our bottom line. So that's 8, 9, I think. I think I did good math. The best math you've ever seen. Let's see if we can get some vision now. Okay, we have something. That's a lot more than 5 rounds. The heck? Oh, 10 rocks. Okay, I want 1 rock. Give me 2 rocks. Okay, I didn't need you to mess up my output. Just show cool vis. Okay, what the heck's your problem? Okay, weirdo. Let's see if this is where it's supposed to be. I think that looks wrong. Aha, so it moved 2 when it should have moved 1. Okay, so I guess... Oh, it's a lot of scrolling here. Ah, I'm not visualizing the rock. Well, that's not right. Where is my rock showing up? If not rock, set rock to object. It's happening right here. So I guess none of these coordinates are on the page. Interesting. Not what we were looking for. I guess I can log. So I mean, we're doing a lot of visualizations here. Let's put 1 visualization after the rock, and then hit it up with a return. So this should show at least 1 rock. Of course it doesn't because it's broken. What's this? I don't know what that was. It's not useful. Okay, so we're going through all the coordinates. I guess highest point in the world might not be highest point in the world because that depends on the physical world. There we go. So we need to go through the rock. If rock highest point in world equals math.max highest point in world or rock.r. There you go. Now highest, yeah, I'm still looking for the highest. Okay, there we have some pretty stuff going on. Okay, now this is working. It's gonna be hard to do this in bulk without timeouts and async and all that fun stuff. Come on, get back up there. Get the lines. Forget the lines. Why is that thing so high up? Why are you in sky? Also, your bottom is supposed to be the highest point, not... The heck are you doing up there? Oh, great. And for some reason, it was never even visualizing. You're also too far left. Dagnabbit. Everything is wrong. Okay, let's actually make this a little easier for my eyeballs. Put the dots. Put the pluses, or at least doing that correctly. Here's we are. There we go, and then what we're going to do these is set let BO equals 0. We'll set all these on timeouts. Set timeout of this constantly of log BO plus equals 1000. So a second delay. Easy. Hey, Jazzy Pants. Yeah, this one's, I mean, I don't know, it's not working yet, but we're getting there. Okay, so it shows up. Then it just teleports. And then now you're 5,000 leagues in the sky. Yeah, we are getting there, Jazzy Pants. Thanks for coming on by. I should do the clear, too. I have a clear. Node.js. There we go. I guess technically this is also the bottom, too, so I don't know what's going on there. Yeah, at the very least, you can figure out... Ah, your 3 is supposed to be 3 higher than the bottom, and then you should like, let's go in the sky. Ah, plus 3. That's not, well, it is plus 3, but it's also plus shape dot length. Make sure you're at least that far off. Which view will be 1. Which we'll find out. Oh, console.clear. Well, ain't that a cool... Does it actually work? Technology, folks. Hopefully this works on the actual... Yeah. Moment of truth. You're a little high. Okay, you did end up where you're supposed to go. I'm glad to hear that. Okay, now you're in the sky, but is that where that one's supposed to end up? Well, that is true. Okay, now what's up with sky? Why are you in sky, huh? Your row is supposed to initialize to what? What? Where will we create new rock? Where is that? Here's new rock. Your row is highest point in the world plus 3 plus this. And highest point in the world is calculated from this. And did I mess up the solidifying of rocks? Rock minus RR, comma, rock minus CC. That looks right to me. So I guess what we're gonna do, what we really do is we're gonna start debugging this. Let's pick a spot, any spot. I guess we'll just figure out why rock and sky. Why sky rock? Hey, thanks for coming on by, Solnix. It can be tough, that's for sure. It's a lot of experience to be honest, but yeah, it's a lot to keep track of for sure. Mainly experience to be honest, and it's always making assumptions and seeing if those assumptions match, so that way you can trust the code you've written. Yeah, naming variable wells also, non-ironically, does help keep track of it. Yep, row is rock 4, row is rock 6, row is rock 333. Where'd you come from? Highest point in world. Ooh, strings are scary. Strings are scary. This is what you get for... Well, I don't know how TypeScript even let this happen. TypeScript, you have abandoned me. How dare you? Yeah, I appreciate that. Yeah, we're making... it's okay pace, but... Yeah, no big issues. No stumpers like yesterday. I will take this over yesterday every day of the week. Okay, I think I did good math there. Wow, that got confusing. Whoops. Exit. Let's see if the visualization looks good. And then if it looks good in the third rock, we'll move forward. Hey, it's all about experience. You know, Jazzy Pants, I just got a little bit more time than most. That looked a little close. Okay, so we got the third rock. Where's it end? Ooh, it actually goes somewhere else. Oh, I stop on 3 rocks. Let's go even further beyond 5 rocks. Going crazy, folks. I think it's not starting on the right spot, though. Or it's off by 1. Or my visualization's off by 1. It's hard to tell. Yeah, right, left. This already doesn't look like the right thing. Ooh, how'd you solidify on that? Oh no. Well, that's not looking right. Okay, let's look at the final one, I guess. Yeah, that L is supposed to make it to the left of this, but it does not. Okay, so I guess we gotta track down who's the first one that failed. So my visualizer was left, right, or once the rock came in, it was 3 above the line. Yeah, these are definitely out of the 5-4 Caillou ranges at this point. They're toughies. Uh-huh. So you are too high on the left. So I think my visualization just literally skips you. It pushes right, goes down, left, then left, right. It's either too fast, my visualization skips. We do start visualizing top right, so I think I just need more vises. Wait a minute. Yeah, rock spawning is its own stage. Is that right? It begins falling not there, but there. So let's add more. Then it pushes right. So push, fall, push, fall, push, fall, push, fall. Yeah, and these are my pushes, and these are my falls. Well, I only have 1 fall. If not rock are solidify, then we fall, or if any of the coordinates are already rocky, then we solidify. Right, that's good logic there. And if I run into something, I continue. Ooh, I continue. Hey, we don't do that. We no op. This is horrible. Else, there we go. We no op. Else, there we go. How dare you not be happy with my bad code? Who do you think you are? Okay, let's see if this looks right. Okay, now we're seeing all the stages, which is better. Oh, and it's also double slow. Okay, that didn't feel right. No, I don't think that's right. We'll see if this one changes. This is a failure. Go left. Oh, I went right. I'm probably pulling out the jets the wrong point. Okay, first rock, jet pushes right. We need to go 1 rock, I guess, because I need to match exactly what's going on there. So only 1 rock. We want the 1 rock. And let's up that speed. Then I can track this one. Yeah, but it does. It is very Tetris-like. Why is that? Why did that not do? Oh, well, it's less than one. Yes, super Tetris. I imagine part two is that they can rotate at some point. Ah, dagnabbit. Okay, I guess I do want two rocks, and I don't want the clearing. No more clearing. We want to see all the rock moves. Ooh, that's a lot of rock moves, but okay, we can audit rock audit. So it starts 1, 2, 3, 4 from the top. 3, so that's already wrong. That's probably the literal issue of all my things. It's starting too high. So who's doing that? You're doing that. So +3, +2. Always leveling off by 1. Yeah, that's a good one. Oh, clear. Okay, let's see if rock. Well, now rock is too far left. Okay, so let's see what you did. You spawned up top, 3 high, move to the right. Now you're 2 high. So you're 3 high, move down, down. Now you're 1 high. Feels like there's a lot of. Why is there like 5 stages of you freezing? Supposed to fall on the right though. There's like 5 stages of you like doing nothing. Is JI not doing its job? If Jets, what's Jets? Jets is this. What is Jets again? Quokka, do your job. Quokka. Okay, yeah, Jets are all of our movements. That is correct. Okay, let's figure out how this works. We get our coordinates. If there's a jet movement, well, there's always a jet movement. No need for that. If jet left or if jet right, we start doing stuff. So if you're all the way left, you can't do anything. Otherwise, yeah, if you're going right, then make sure you're in the right thing. Otherwise, yeah, both of these appear to be happening. This one never runs, but we don't blow it to the left yet. Okay, okay, so I'll put a viz. No. Viz right here. Well, before rock, with rock, on this, and then on this, and then on this. So we're gonna get a lot more stages than we asked for. Our viz, we're also gonna want to see the J. We want to see what J we're on. So I think we have access to this. There we go. So yeah, I guess we'll just go ahead and shove it right here. Why not? We'll have a good template literal JI to string add start with 2 and 0. There we go. Just show cool stuff, Don. You. Oh, great, because it's all out of sync or whatever. Oh, wait a minute. Oh, yeah, because I grabbed the value. Let JJI equals JI. There we go. That's what we get for doing timeout trickery. The price I have to pay. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8. So we make it through a lot of wins. But let's see. We start off with 0. Then we go to 1, 2, and 3. 2, 3. How'd you go without going down? But I still have a continue lying around some here. Dagnabbit. I've done it again. And less than 7, I guess. Oops, I did it again. Yeah, that's just my brain. I need to be like, where are you? Well, now it's way over there. But hey, I like how it didn't like it followed Tetris rules at least. And now it's way over there. So yep, we go over there. You blow to the right. You move down. You blow to the right. You move down, and then you So you go down, then you solidify. We need to... Well, firstly, you go to the corner, and then you get pushed left. Okay, so it's technically once you hit -1 or whatever, so you can move when you're on the floor. Again, very much Tetris rules. I think we're inventing Tetris here, people. So if rock R triple equals -1, then we're going to be like, uh-oh, rock.R, you go back to zero land or something like that. And do stuff. Do all the cool stuff. Let's see if this puts first rock in correct position now. Okay, first rock correct. Second rock, no! What have you done? Okay, second rock rules now. You spawn 2 up from this rock. You're supposed to spawn 3 up from this rock, you darn dumb rock. Why aren't you smart? So your row is 0, 1, 2, 3, 4, 5, 6. You're row 6. You should be row 6, but you're row 5. Or did my visualization just fail? Wait, I'm blind. Yes, I'm wrong. Nope, I'm right. Okay, this is where you're supposed to be. 3 high along this one. So at least to the left, which is the easiest math, is working. So I think for the first one, plus rock shape plus rocks stopped equals 0, plus a 1, plus a 0, or a 1. So I added it, then I removed it because of the first rock. So I think first rock is weird rock. Good rock. Good rock. Ooh, these are 2 good looking rocks. Okay, it's time. Let's put a little more debugging symbol in here. Right here is where it goes, and then it's gonna be jets JJI, so we can see what that is. And with that, we're gonna go add the clearing. Increase the timing by a quad, I guess, and go 5 rocks. That's gonna be a lot of visuals. Okay. Again, it seems like... Well, I have so many in this loop, I forgot. Then go left. Good. It solidifies. Goes left. Now we go right. Now we're gonna go left. Then down and right again. Okay, I'm understanding. Now left when you should eventually end up on the left side of this thing. So 2 more lefts. 1 more left. Ooh, no. Okay. You decided to solidify because your new coordinates were still over here for whatever reason. Your shifting to the left did not update your coordinates. Yeah, we're close, Jazzy. We're close. I mean, we're inventing Tetris here. So new points is coordinates. Aha, what are coordinates? So coordinates are pre-shifted days. So I should calculate new coordinates. And I thought I did this, but my copy paste brain was like, we good. Coordinates.splice. Fun fact, however you want to empty an array, but when it's a cost, you just be like, get rid of all of them. Starting at here. I think that works. There you go. We empty our lovely array again into the Tetris. I could have made it faster, but I do want to be able to track this. Or I could remove a couple of vises, because I think one of them is completely unnecessary. Yeah, it does feel a bit dramatic, doesn't it, Jazzy? I mean, honestly, I might keep this visualization code around. Just basically doing what I would visualize anyway. Okay, moment of truth. Good. Okay. I don't know where this thing's supposed to go, but I guess we'll just follow its... Did it just do a shuffle? I don't know. I think it might end up on the other... Oh. Okay, I have to actually... We're gonna step away. Up the 2 T's, this will end up on this T. Go to the right. Go to the right. Yeah, okay, I'm done visualizing. Let's give this a run for its money. I guess turn off the visualizer, hit up the return statement. You served your purpose well, good visualizer. And we're running for... Now here's where I go off by one. It's either going to be too few or too many. Okay, and now it's going to be like, haha. Console log, because I don't have the number on hand. It would be cool to see some kind of tracking, so I guess whenever I make a new rock, I will console log highest point in world and rocks stop, just to get some kind of where the heck. Ooh, you finished, Quokka. Big fan. I broke. Great. Okay, wow, look at that. Yeah, 1,000 rocks in. This isn't taking long at all, which means part 2, we're gonna have to sweat. Oh, Quokka beat me. Oh, 306.9, 306.8. Ah! Okay, it's off by 1. We got that. Time to run on the real one. Now, I might need to turn off the console log for this, because we know console log is not a free action. Whoops. Why is my code not running? I commented it all out. Ooh, look at them jitters. I mean, you might not see it on the frame rate, but it's jittering a little. It's just true. Yeah. True at heart. Oh, 306. Uh-oh, I goofed. Input. This is supposed to be real input. Um... Um... Look at our jets. How many jets we got? We should have like hundreds of jets. If this is 17, run it again. Okay, you're gonna take a moment. It wouldn't. 2022 rocks have stopped falling. Yeah, 1,000 jets, as we expected. 10,000 jets, rather. Yeah, that's based on length. Oh, here are 2 numbers. Oh, that's the old one. Console log. Oh, I'm returning it, or... No, I'm returning this. Oh, that's the other dumb one. Go away. Go away, you confuse me. 3068. Now I knew this was off by 1. In this example, what's my real examples? I must have gotten something wrong. I wouldn't get the same one. Solve 1 data. Yeah, we're using the passing parameter, yes. Even Quack is confused. 3069, 3068. So is it literally 3067? Wow, my brain. Okay, well I just burnt like probably a few spots on that. Oh my goodness, big math. After this many rocks have stopped. Well, this wasn't what I was expecting. How long? Let me just do bad math to see how painful this is gonna be. Oh lordy. So many optimizations need making. Well, if it's a pattern, oh, is this pattern detection or something? Yeah, Jazzy Pants, I got by that. It's like, no, that's not like my own brain just got in my way. This is gonna be tough to basically just run it for more, right? Okay, it takes 28 seconds for that. It's only gonna scale linearly, so I'll need to detect the pattern, right? It's a pattern in here. Or a cycle, right? Huh. Cycle detection. What would cycle detection look like? Hmm. I need to keep track of basically everything I've seen, and then once I see it again, I'm like, I see you. Hmm. Then I'll do math. Okay, maybe I can go to part one, just find. I guess I'm finding the number of repeated rows. Well, it's not. I need to count rocks, though. Interesting. Some kind of detection of repetition, because I can't. I don't know, folks. I don't think I can run a loop that is. Is that even a real number? What was that? One of those terabytes or petabytes or gajillion Google numbers? 12 zeros. Come on. Come on, you gotta at least have a number. The noun that is represented by one. Come on. Oh, it's a billion. Never mind, I'm blind. But yeah, we don't deal with numbers that big, do we, Jazzy? We need to figure out how to run this basically more. It's gotta be cycle detection. Which means I guess I can, okay, so I can make one visualization at the end, try to visually spot it. It's gonna be a scroll for a lifetime, but it's gonna be 3,000 lines of a scroll, to be honest. No, that's not really gonna help. Hmm. So this is, I do have a world. What I need to do is try to serialize it in some way. Ooh, this is a scratcher for sure. I mean, hey, this is at least conceptually easier than the last one, so I'm not really complaining too badly. Hmm. Interesting. So I guess I do need to visualize this. I was like, I can think of it, I can't think of it. So what if I visualize each rock of a different character out of a set? That might make my brain easier. Throw it in a do while. Yeah, unfortunately, Jazzy, we ain't got to the heat death of the universe to run this. Okay, so where's my rock character? Be my rock. So where's the world? Yeah, world get this. So what do you do, world? World dot somewhere around here. Has, and set. Great. This is gonna be, I guess, RC, or let VC equals. Let's take this out of the loop. The loop. Rock cars, and then we're just gonna make a cool little thing. We got these ones, these ones, these ones, and these ones. Great, lots of symbols. Now we're gonna go down here and say, look, our lovely character. Cost car equals rock cars. RC VC plus plus. Same logic, the last three ones. If VC greater than or equal to rock cars dot length, VC equals 0. So that should be enough, and I'll just use this character now just for sanity. And you know, we don't need Sandy where we're going. Let's let her rip. For the easy one, not that one. So we're not letting it rip just yet. Now we're letting it rip. Hey, I don't need that anymore. Great, okay, so we are literally not visualizing anything with my cool symbol. I love that. Big fan of that. Oh, what's using here? Oh, this is it. Whoops. See. Use my character, not yours. But hey, look at this lovely tower we got. And if I can visually, here's the thing, it's hard to tell one rock from another. And its height after X amount of rocks. So I need to find the rock state that exhibits a pattern. Okay, great. Look at all our lovely rocks. So we got 1, 2, 3, 4. Okay, this is a lost hope, it feels. 'Cause I thought I just saw a pattern right here. Nope, it's different. Oh, here's my pattern. Nope, not my pattern. Nope, not my pattern. Nope. Okay, I do think I see the idea though. What I need to do is I need to serialize the entire world, then see, hey, have I seen that world before, and when did I see it? Yeah, Jazzy. I think I have an idea for it. It's not gonna be cool, but I think my idea will work. In theory. It's a game theory. Here's the thing. I'm hoping 2023 rocks is actually enough to find this, though. And let's see. So cost patterns equals new map. This is gonna be tough. Um, what was I trying to do again? So basically, after each dropping, I need to say, okay, encode the entire world. And if I ever see this encoding again, no wait, that's not gonna work. Because I'm encoding the entire world, it'll be the entire world, which will contain a repetition, but not one visually. What if I encode the last end line? So I like, is this a pattern? Is this a pattern? This a pattern? And eventually I find it. This is always from the bottom, though. What if my cycle is not bottom based? Oof. Okay, that's another tough one. How close did I get? I'm curious now. Give the brain a quick leap off. Ah, 1,000. Not too bad. Okay, we gotta do some kind of detection. Hmm. I mean, can I just run it for this long, maybe? Maybe I just do run it really long. Hmm. I do need to keep track of this somewhere. That's a big number, too. I might have to drop into the big ints or something. Hmm. It's a tough one. It's a tough one. Hey, of course, Jazzy Pants. Appreciate you coming on by. Yeah, these part twos are always tough, so I know. And yeah, I'll catch you the next time for sure. At some point, I gotta save my pattern. What things do I get to save, though? I can't save the entire map. That's not an option. So I save my current step again. No, I can't save the rock stop. That's not useful at all. Hmm. Alright, so I have to identify the pattern. Something lets me figure it out. A, of course, of course. And yeah, they, like I said, like we all said, this coding, competitive coding is not exactly what moves the needle during the job at all. It's not what people do during the job, so don't feel dumb about it. It's a very much its own brand of problem solving. Right. Hmm. If I keep track of the mal, ah, interesting. So once I create the rock, it's always going to be going down or left. I do the cycle detection when it lands, right? Right, right. So landing is not really in here. This is the entire logic. So when I land, I try to perform the cycle detection. So what do I save when I land? I guess the visualization would be helpful at this point. Let's get that thing updated. So here, boom, what would I save? Or what would I say on rock creation, maybe? Maybe that's why I save stuff. Mm, a tough one. At least on the last one, I knew somewhere to go. Cycle detection, I mean, like, so you do have linked lists, but I don't really know any other cycle detection methods, unfortunately. Okay, I'll try Googling matrix cycle detection or Tetris. Since this is so Tetrisy, detect cycle in 2D grid? Huh. Tetris, no, I don't want that. I want cycle detection. Adjacency matrix, that's kind of not right. Hmm. What I have to do is there's something I gotta save previous state. If I save the entirety of the previous state, then it's always I need to save the entirety and a subset. I mean, don't I just care about the heights? Hmm. Okay, maybe. No, okay, I wouldn't even know how to generate a cycle to detect though. So like if this is one to the left, for example, this would be a full cycle I could somewhat emulate and all that. What would that look like in code though? Because I'd build up to here and I'd have this entire bit serialized. And I could build up further and see, oh great, the bottom half of me was serialized. Would that be what I do? That might be what I do. Something feels wrong about that, though. So that's what we're going to do. We're going to, every time a rock lands, we will serialize the entire world below. Might even choose strings while we're at it. And what we'll serialize is the world and the current. I guess we just need the entire world, right? We don't really need the rest of it. And the height, I guess that matters. Okay, yeah, so let's try that. Every rock landing, we serialize a world. So patterns, and I hope this small test case actually has a pattern. If not, I don't know what we're looking for. There we go. After we stop the rock, we are here. Before we, I guess we do serialize it right there. Then we want to convert map to JSON, sorted, all that, so it always checks back. Yeah. Just how them out all easy. Yeah, I mean, them elephants should be super small, but super smart by now, right, Cletus? We taught them a lot last problem. Patterns dot set key is I guess the key is the serialized world. World dot. So let's see. I want this. Well, maps are ordered, correct? Yes. So can I not just convert it to an object and be like Pluie? Yeah, well, I don't see why I can't convert it to an object. So what is that? That is object dot from entries, and yeah, we're gonna use a string because we are cool people. We're gonna say dot entries, congratulations, and then we're gonna be like, aha, JSON dot stringify. What we're gonna include with this pattern is the oh so important rocks stop. Hope that math is right. And this should do the trick. Okay, we're gonna turn. That's already here. Yeah, let's see if we can get a pattern within 100 rocks. Well, come on. Nope, come on. Must have hit an unlock at some point. Whoops-a-daisy. Yeah, thanks for coming on back, Cletus. Hope your day has been treating you well. We got some patterns. Well, technically, yeah, we are saving every pattern, so say goodbye to your RAM. All your RAM are belong to us. So here's the thing. We're going to be, hey, we have our lovely pattern. If we've seen you before, we want to do some math. Key equals lovely key. If patterns dot has key, then we want to increase our thing until we get there. Oop, we already have an if. Well, this is for an empty key, of course. We're going to have an if. Awesome. Looks like we do have a thing. Console log patterns dot get key. Please don't be a dumb number. Never mind. We don't have executions. Loving that. Absolutely loving that. 0, 2, 0, 3, 0, 4, 3, 2. So what I have to sort these. Oh, great. The symbols are all wrong. Let's fix that. I'm back to the pound sign for you. We are only going 10 rocks, I suppose. This is where the stringification version would actually help. Oh, while you scroll. I don't think the order actually matters, does it? And these are all incremental on each other, so it's easy to kind of follow. If I did, okay, I would, I could. Let's just see if this ever actually happens, though, right? Let's give this the big number. Yeah, Quack is gonna have a field day for that. Now we're getting there. We have ideas. And none working, of course. Quokka is freaking out. JavaScript's freaking out. It's like, you're JSONing too much stuff. Okay, this isn't the cycle of text I'm looking for. Yeah, I mean, we haven't gotten there yet. I mean, last stream, my computer's monitor was like toodaloo. But that was a little bit unrelated. Oh, great. We didn't find any of our patterns. Lovely. But we have butt ton in here. Okay, so that has been very useful. Super useful. So whether my serialization has failed or there physically is no pattern in 2022 loops. Loops. Hmm. I also need to also serialize my matrix, don't I? Or like not my matrix, my current wind tunnel. So I'm glad this didn't work, because this would have just been in my way anyway, I suppose. Ah. Hmm. Tough one. Toughy, 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 toughy. It's not gonna be this. You know, that kinda. So we need to keep track of, I guess, our current wind pattern. So we definitely need our wind index. And the next rock. But it also depends on the previous rock. It also depends on all the ones technically below that position. It's in here somewhere. Detecting this cycle. Hmm. Oh no, this is a tough one. Um, I mean, I guess I can turn back the visualization on to get some insight here. Turn these off. Very useful. The most useful code. Oh, we don't want that visualization. We want this one. We want to turn our characters back on. I'm gonna Lucky Lou. Lucky Lou. Lucky Lou. Hmm. Okay, here it is. Lovely Duffy. Can at least find the pattern. Oh, come on. Okay, copy. Search. That's not the pattern. There's our pattern. Okay, so it is generated in this particular example. How do I find it? It is in here, right? So, yeah, we pillar. So, yeah, we T. No, that's not the pattern. Never mind. I was wrong. Also, not the pattern. Wait, no, there is a pattern. It's just not from the initial thing. See, that's what I kept on complaining about. How did I find this? 1, 2, 1, 2, 1, 2. Right. How do I identify this? So, like a watch. When I skip 2, you'll see it. See, like you can identify this entire section right here. There is the pattern. Yeah, pizza, pizza, 1, 2. So it's hard to tell, but there's a pattern of this Tetris droppiness. We have to programmatically identify it, though. It's in there. I appreciate the all the health redemptions. We got part one in the 10,000 though, so that one wasn't too bad. The thing is, they want us to run this for 1 billion. That's why we're trying to cycle detection there, pizza. Yeah, Matt, it's not. Again, it's a tough one. It's definitely a toughy one. I mean, it's basically we simulated Tetris without the rotating for the first part. For the second part, is a lot more Tetris. But yeah, my brain's not figuring out how to detect the cycle. You're not wrong, pizza. I mean, Moby Dick was easy compared to this. I must say it. Okay, somewhere in here there is the cycle. Wait, so does that mean I need to traverse until I start the cycle? But how do I detect the darn cycle? Yeah, it's on more the level of that one for sure. So it's basically this pattern here, right? You got the little block, the giant empty square. Little block, giant empty square. Little block, wow, the pattern is actually very short. Hold on. Oh, wait a minute. Okay, then you have a cute little door here. So basically, it's asking us, great, I run it for 1 billion iterations, which we can't do. But basically, let me try, maybe re-identify. Nope, I've lost it. Yeah, I think, it's hard to spot. Let me try to eyeball it again. There you go. So like basically because they're being dropped in a pattern, so you can see like from this point on, like yeah, this square of five, then you have this shape here. If I jump, you'll see the exact same, like visually. The shape is the same. Whoops, I did it wrong. But that's the pattern we have to identify in the code so we can mathematically repeat this sequence instead. The hard part is trying to be like, okay, and like we have to store the pattern and get it back out. And I don't know what data we're supposed to be storing in memory for all this fun stuff. I'm not even sure. Yeah, again, I'm not sure. I don't know what I don't know. It's all good. It's all good. I appreciate it. Yeah, but at least I got this cool visualization. That's fun, right? Yeah, let's have some fun with this. Let's turn this thing back on. Cause this was fun before it all got crazy. Eh, turn all the visualizations back on. Turn the lights back on, people. Turn back on the lights. Essentially, yeah. If we ever see the same pattern twice, then we can just do math and be done with our day. Well, don't do this to me, TypeScript or VS Code. Someone, why are you doing this to me? Okay, we'll turn off clock. Computer be like, how dare you? 500. Yeah, it's not that many. It's 500. Visualize, Danu. Okay, it's coming loud out louder here. It should be fine. Now, wow. Okay, I guess scheduling 2022 is a little much. We'll schedule 10 rocks. Be cool, VS Code. I probably should clear it too. There we go. But hey, we have this working. So this is a success in my book. It's It's showing Tetris or showing their version of Tetris in a cool visualization. We needed this to debug the thing. Oh, we don't want search. But look at it go! Wow! It's something. It's a little slow right now, but at least we have that working. Visually, wait, is it possible to ever shuffle? Because we care about the top, like a top-down laser scan perspective, right? That's our pattern. Because, well, here's the thing: a small block could go down here, then shift to the left and get stuck somewhere. So maybe we don't do that. Oh, we had to generate something like this. So what we do is we generate 1, 2, 3, 4, 5. We generate these numbers and the highest most y's at those coordinates. So at least in this behavior, I've yet to actually see it, like do a slide under something. Oh, unless you're about to. Okay, great, you got stuck. Oh, weird visualization. Yeah, actually, let's go back. Let's do the super viz. I'm gonna see if it ever does get stuck, and if so, this will throw that theory out the water. But if not, then this theory holds water. And then we'll need to store the current rock height, current vertical view, and it's not vertical view, it's vertical depth though, isn't it? Something like that. Okay, let's see if any of them shimmy under each other. Yeah, everyone's stacking. You're ooh. Uh-oh. No, that one's fine because it doesn't collapse that vertical view. Okay, we lucked out there. This is across. Maybe it doesn't matter there are holes. Maybe that'll work. Okay, let's think of that then. So we want to. Did we go through the last? Interesting. How high are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, like this one, for example, you're looking down freaking 30. So maybe this. Huh, maybe that's not the idea to do it. So I want to get the maximum Y for all of these. And then I want to get. Interesting. I want to get something. What do I want? Ah. Excuse me. Hmm. Yeah, it's a toughie. I think visualizing or serializing the highest of all of them, not the highest of all of them. I mean, the highest vertical location. Maybe that'll do. So from Control C. So from here, it'll be. It's technically all four of them. Nope. Ah. So we're definitely going to be keeping track of ours. So we know one piece of information we need to code to find pattern. It's pattern. We need current JI for the jet. Yes, we do need the jet eye for sure. We're also gonna need what other information? Current piece index. So we have to make sure we're placing the right piece. Jet index, piece index. We need something else. Oh, man, actually calculating this math's gonna be tough too. Hmm. Huh. So it'll be definitely generating through the grid, but I only want to care about the maximum y for every x. So at this point, the maximum y for every x, so for this is technically the maximum x for every y, or maximum row, or a minimum row in this case will be 0, 1, 2, 3, 3, 3, 3, 3, 1, 0. Now if I ever see 3, 3, 3, 3, 3, 1, 0 again, well, I'll never see it again, because this is from the bottom. It'll need to be from the top. Oh, maybe my math of choosing 0 as the bottom is now gonna haunt me. Ooh. Not good. Not good at all. I could flip the math around like how I do with the row offsetting. That would do the trick. Hmm. Hmm. Maybe we just only look at the top n rows, right? So we look at the top so many rows. If it's the same, that's our pattern. Okay, maybe yeah, we'll try that. We still need to store all this other information, though, I think. Or maybe we can just paste the top 20 again. Hmm. Ooh, this is a tough one. Hey, I appreciate that, Matt. Yeah, of course. I will catch you tomorrow. Sure, I'll figure it out eventually. Eventually, I might need to rewrite this, to be honest. This is good for a simulation, not exactly for this stacking monstrosity. Hmm. Hmm. Yeah, so I do think the peaks is a great idea. So I have to figure out how to implement that to be visually detected or to mathematically work with my freaking thing. Minus from the top, I guess. So here, at least before this rock shows up, it's 0, 3, big number. Okay, maybe that's the way I'll keep it. Yeah, so it's definitely the rock, the the thing, and these 7 indexes. Or 7 numbers in some way. So I guess I just gotta calculate these rocks. Okay, so the depth. Ah, that's it. 7 depths. Depth from top. Yeah, there we go. Okay, I can figure that one out. From highest point, I calculate depth from top after the placement of a rock. So after the rock solidifies, there we go. Great, it's the 3rd time this code's been in this base. Like, why you keep copy and pasting me? Because you're beautiful. Great. So now we're going to go through each of them. And we're going to go down until we find it. So, or const c, or let c equals 0, c less than 7, c plus plus. And then we're going to go for let r equals 0, r, while, actually it is for loop. Let r equals highest point in world. I guess this is accurate. R greater than or equal to 0. R minus minus. Here comes the fun part. Great. Okay, if world.has, then R, comma, C, then break, or peaks. Let depths equals this, then depths dot push, pushing the row, because that's all we care about. We don't care about the row, we care about the depth. So that is large number minus small number. Highest point in world minus this. Now that might be 0, but it could be anything else. Now once we have our depths, we're going to say patterns dot set. And this is where we start stringifying our thing. Const pat key equals lovely, lovely, lovely. So the 3 things we care about are our depths, which thank you JSON, or thank you JavaScript, will stringify your JI and your RI. That's rock index. Yeah, that's rock index. There we go. Now we're gonna say great if patterns has hat key console log patterns get rock hat key. I don't even know what I'm storing in here. And I guess we'll go ahead and throw a return just to get life moving. Otherwise, we're going to set it. What do we actually care to record in this, though? I didn't think of that part. The number of rocks we currently have stored. Yeah, that's what we want. The current number of rocks we currently have stored. Rocks stopped. Okay, great. I guess we might as well output pat key while we here. Hopefully this shows up in 2022, or else, again, I think I've seen it. Oh, we don't want these. No, 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 we have a timeout in there. Be gone. Foul. Timeout. Uh-oh. Okay, this is happening every stop, so there are only 2022, and it's not that many. I guess I kind of just assumed my depths were working. I might have checked that, but I didn't. Visualization might have helped check that, but I didn't. Ooh, it's not what we wanted to see. Okay, so my depth calculation probably isn't correct. It's okay, we have the debugger. Bugger. Okay, let's figure this one out. Yeah, so we already figured this out. So our depths are all zeros. Well, excuse you, there are 4 of those. What the heck's going on? What the heck is going on? Oh, because they're the only ones that reach to the thing or whatever. Huh. Okay, I guess we're gonna say greater than or equal to 0. If not, or else, if not R, I guess we're pushing the U2.
I mean, that feels like something that only would run in the first, but we're making sure it's cool. Yeah, great. So all seven. It's not really accurate though. Uh, highest point in one. I guess we can levitate a little bit, all right? So highest point in world, decrement by one, just to get a more accurate scanning. Wow, absolute travesty. How did that go so badly? So badly. What's in the world? Where are you? Show yourself. Yeah, you got four of them. Zero. Yeah, that's your row, and you make it all the way to zero. What is your big idea? If world has RC, push it to the depths. Otherwise, don't. Okay, well, again, gotta fix this bit of code before anything works. Get in there. There you go. Oh, row is -1. Whoops daisy. Since I flipped it, man, I'm really regretting flipping my axis. Flipping the values of row to be zero bottomed. Great, we have depths. Dag, nabbit. That's it's not no -1 minus R. There are only supposed to be four ones. So I went the wrong way, didn't I? Okay, there we go. Four ones that represents the view. Next one is God. Okay, when these happen, we need to exit. So when both of you happen, let's add some curlies, break. Phew. My word. Again, forgot the looping nature of a loop, apparently. Okay, first one, easy. Second one, easy. Okay. So 3, 3, 2, 1, 2, 4. So we have three blanks on left, 2, 2, 4, and then one on the right. Okay, so that's for our second rock. So rock 1, and then rock 2, we have 3, 3. Well, it's not really 2. Okay, or sorry, scanner's sitting up here, I guess. So 1, 2, 3, 3, 2, 3, 3, 4, 4, 3. Bad math here. I want +1. We just want the number 0, don't we? Yeah, we want the number freaking 0. We'll just 0 it out. Make this easier on our life. I don't think it actually matters for the above views. We can go one extra pattern, right? Okay, there, that one looks good. 0, 0, 2, 1, 2, 4. Good. Now eventually, get that right angle is still giving us a lot of things. But once we smush down, we have 2 on the left, then a 1, then a 3, a 4, and a 6. Lovely. Now, next iteration. Wow, okay. When's something going to show up on the right? Something show up on the right. Please, Jesus. Come on. Wait, how long does it take before someone fills in that right slot? Any time now. Ah, the travesty. Okay, that was a little painful. Also, I just realized that this does not look pretty, or it doesn't look determinably ASCII or whatever. So let's drop these in there just for readability's sake. And I guess we do have to actually math this one out instead of dropping a 0. So it's highest point in world -1. We just gotta get this right. So trial and error until math do math what. Great. Zeros there. 4, 3. Nope. Maybe it's a math max of 0, so never below there. But oh, fresh again. Hey, at least it started working on the end there. Come on. No, you. It's a math. Okay, so I guess we're gonna do. We don't want to hard code this one. Ah, freaking weird edge case. Right, so that one works, and then we have 3, 3, 2, 1, 2, 4, 3. Because up here it is 1, 1, 1, 2, 3. It's not even right. 3, 2. It's not right. 1. That's sonar. Oh, this is kind of like sonar, yeah. 2, 3, 4. Then I guess once we get to -1, we're like on fire or whatever. Maybe as long as this pattern is consistent, it will work. Okay, I'm gonna hope the consistency will save us. Do we actually get anything ran here? Do we ever see our pretty pattern? Ooh, we find our pattern very quickly. Now we have to actually figure out how to iterate through our pattern. So that's the fun part. So I guess we will, once we find our pattern, so we console log our pattern and our pattern key 28. Wait, that's not. Rocks stopped. What a coincidence that is. Let's keep this going, actually. I want to see all of our patterns. Oh, it's hard to tell if it's the same one. Okay. Okay, so 16, 15, -4. 16, 15, -4. Oh, look at that. 16, 1, 5, 3, 5, 4, 5. Okay, yeah, that's cool. So I guess we want the... Yeah, we want to keep going. Once we get past 2022, we want to search for our pattern. So we'll keep saving them, but we'll only look. Hold on, how does this work? Ah. So how do we... Like, we just got a lot of them. Do I just keep repeating 28? Because that's literally gonna, like, that's not gonna be enough for me to get to a billion. Yes, like this one, what, I just continually add 1, 1, 2, 4, and set this thing to that. That's how I fast forward by. Because I just saw this one literally up a few lines ago. Yeah, come on. Copy, paste, search. Yeah, there are literally 30 of them, and you are showing up right, literally like 40 lines apart, or like 140, whatever. Yeah, literally 109 apart. So that's not a large enough scale, to be honest. Hmm. Ooh. That's a toughie. Yeah, so we keep track of our peaks. this, that, and the other, and then once we see one, I guess we just fast forward with it. Yeah. How do we do the fast forwarding at least? So if we have it, then we got it. Cost additional rocks equals patterns dot get hat key. Sure. So now we have this. What do we do with our life? Actually, we can keep that there. That's fine. So I guess we say, I guess we update all of our accounts, right? So const. Ooh, I didn't serialize this. I'm not gonna be able to pull it out. Okay, I guess we're serializing you. JSON serialize depths. Okay. Well, hold on. Stringify. There we go. How am I just going to like append the thing to the top of it? Oh. Oh. Wah, wah. So I'm only keeping the peaks. And I want the height. Oh wait, I can just add that to my current value, right? Hey, the Brosbit, this is TypeScript. Basically JavaScript with types. Though I'm not using too much actual TypeScript here. It's mostly JavaScript. Thanks for coming on by, and we are solving Advent of Code Day 17, Part 2. A little tough because we're looking for some kind of cycle detection and basically a game of Tetris that we are simulating. And I've detected the pattern, now I just need to make it work. Somehow. Some way. Yeah, I hope your night has been treating you well, or wherever it is, wherever you are. Rock stopped plus equal additional rocks. And then I guess we're going to be adding to the world for cost peak of, for const depth of JSON.parse. We don't want hyphens. We want vertical bars. Hey, yeah. I mean, yeah, you definitely JavaScript's gonna be a little bit easier than Java. They aren't related at all, but Java being OOP as it is, much more structured and stuff, which it could be easier for you, but JavaScript itself is much more freeing, lets you do a lot more at the cost of letting you do a lot more. And considering it is the #1 technology for front-end web development, you can't really do it without knowing JavaScript. And same for at least full stack, because if you're using JavaScript on the front end, you can also use it on the back end, though. As you know, you can also do Java on the back end too. But yeah, not too hard at all. Usually one's first language is the hardest to learn. But if you want, there's a free training program, or there's an agency called 100 Devs with a free training program. Since you already know Java, you can probably zoom through a fair amount of it, or at least when you get to it, it'll all no new concepts, just new syntax for you. Hey, of course, Ryan. Yeah, this is a tough one. Yeah, usually, at least in my experience, Java taught me a bit of, or at least college taught me a bit of an antiquated version of Java. Like, it was just to learn the concepts. So there you'll learn a bit more modern. And of course, the one thing that kind of sets it apart from any YouTube tutorials is that it's free, obviously, and it's the community that matters. So I know there's at least some community in college, but at least mine was very scarce. Actually, I already have the depth. Ah, freaking math, folks. Freaking math. Yeah, this is not what typical JavaScript looks like, by the way. This is Advent of Code style coding. Very messy, very
Please work.
Ah.
Math. Big math. Mm. Ooh, it's a tough one. Mm. Hmm.
Maybe I could manually find this cycle or find the find something.
But it wouldn't be a fierce cycle because there's still that run up bit or the build up to it. Hmm.
Ah. Huh.
Hmm. Because the problem is like if I do go additional rocks, there are additional cycles that still need to be ran, and I can't run them now that I've kind of skipped ahead. Hmm. Yeah. It's a toughie. Hmm. Okay, so it's gotta be like I found the cycles. I just need to do something with them. So I have my heights. Have both indexes. Do I need something else? Maybe I need more data, right? So the depths, the jet, and the rock. So it's definitely still happening here. Right? When the rock settles, we got that part. Ooh, freaking math. Never once. Okay, what if I were to quickly simulate one?
Alright, so all things go left. Or yeah, all things go left. Could I visually simulate? Stop doing that. I basically need to build my own test case because this one is too overwhelming. This is the part where you visualize it. TypeScript. Oh, it has to run. Great. Great. Okay, so you shoved it on the left. Can I see my pattern? Yes, I see my pattern. Now let's say this is 1, 2, 3. Isn't there an L? Did my rock simulation break now? No, now what's wrong? What now? I guess we don't need the 2000 anymore, so we'll need 25. But now it looks like something else is broke. Wow, that's not 25. Excuse you. Who do you think you are? It's very less than 25. 250. Don't know why that broke. That is 2 rocks. A good person. Great. Good. Here's the pattern. There it is. So this is an... Oh, it's a right angle, not an L. Whoops daisy. Okay, still functional though. So as you can see, there do be a pattern. Well, it's hard to pattern because it's all... Darn it. Nag nabbit. Is it an even or an odd number of rocks? 1, 2, 3, 4, 5. Which means lefting and righting 1 and 2. Well, let's go ahead and give it a shot. Where's my thing? Where is it? Come on. There we go. So if we just do a little shuffle dance, will that be visually repetitive? Yeah, essentially vertical. Okay, so now we see it. We see it again. Dang it, we still got the problem of it all. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, hopefully that balances out and actually gives me a depth. Great, so all of those, all of those, all of those. Nope. Now, where the heck? I lost my triangle or my square or whatever. Oh. Oh, that's broke. Okay, go back, go back. Put those back. Hmm. Tough one. Maybe if I look at the top 10, it will be enough. So let's do them all back to the left. To the left, to the left. I'm going to look at top 10. So where's my pattern recognition? There we go. So it's this minus 10. There we go. So if we just look at top 10. And if you don't make it, or like if you didn't push to depths or whatever, or something dumb, I have to push other logic here. Great. More stuff. More stuff. Depth.length not equal C, or if triple equals C. Depth.push, highest point in world, -10. Hopefully that's enough patterns. Which should... Oh my goodness, this thing is still in here. Hopefully they didn't break anything. Yeah, pattern recognition should start here. Well, that's not debugging it, but we should see it there. Or not. That's cool. We don't need to see. How did you do that? Okay, it's my harsh hard coding 10, not doing math. Because math's always gonna go up. Let's make sure. Okay, there we go. So 1 1 1 0 3 4. Yeah. Oh, pat key. Yeah. Pattern key. So it stands for pattern key. Let's have other paths. That's just the one. Yeah, cheers. If only that was it. If only. Okay, then we top out at 10, right? Great, we top out at 10. Then we do it all over again. And then eventually we'll show 4 1s. Come on, you. Bingo, we found the pattern. Now what do we do with this dumb pattern? So what rock are we at? What rock are we at? We're at rock 11. This is very amazing for us. So say we want to get to rock 50, right? We want to get to rock 50. That's our real goal in life. Get to the 50th rock. How would you do that? First, I guess I'm going to hard code this and see what 50 rocks actually returns. So stop, return, give me a run. Should be 110. Great, now time to do the cool math to figure that out. So here, jump right into the sauce. Okay, so we figured something out. Where did we figure that out at? So we're at 22 high, 1 1. Oh wow, we actually found it at that pattern. Well, aren't you fancy? Yeah, so we're getting additional rocks, which is, let's go ahead and run this while we're here. 5. 5. 5. Okay, I mean, we're going to take what we can get. And we're going to be like, oh, great, while thing is happening, while rocks stopped plus additional rocks less than goal 50. I'm just hard coding it. Then we're going to do say rocks stopped stop plus equal additional rocks. So this is the fast forwarding. Zoom, 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 zoom. Then you're going to update that with that, I guess. Oh, that makes the pattern not recursive, but it'll do stuff. We're going to see how this works. It's hard code 50 to be our goal. Where's our number? There it is. Goal. We love a big goal. We are goal oriented. Great. Love goals. Well, let's make a goal variable. Now we know it's supposed to output math 1110. So let's see if we are doing just that. So this should fast forward and then stop just before it gets there. How dare you? Do I need to put these? Yeah, so I'm adding rocks, but I'm not increasing height. Understandable. Okay, so for every time we do this, we need to add to the world, highest point in world, plus 10. Interesting. I don't have the depth. I can't calculate how high to go up from there. Very interesting. Phew, you know what? This is Let me see if anyone Hunter does happen to some insight. Nope, stumped as me apparently. Oh, tough one. So I have these numbers, and these are the peaks, and I need to add them to my current peaks. I need to increase my height. Go forward one step. No, that's not the step I wanted. Okay, great. Additional rocks. Go back up. Where is it? Where is my data? Where's my data? Get me out of this loop. Okay, bad code. Okay, let's get out of here. Okay, additional rocks is 5. Doesn't tell me how higher I got from this 5. Oof. Very, very tough. Well, I think this one's just on me. My brain is not loading this information. Usually I at least make it to 20 before it starts taking me 3 hours to get through these. I guess they ramped their difficulty up a little bit this year. Hmm. Okay, rocks stopped. We've stopped 10 rocks currently. We've stopped 5 rocks when we saw that last. Which means we're adding 5. And we're just adding 5, right? But our height is not going up. So do we just take these and move them up? Yeah, so we go through all of these. We get the heights of blocks. Yeah, so this one is at position 21, 21, 20. Okay, I think I see it. I think I see it. And by add it to highest point, no, I don't. I say 21, so that's the offset. I need to add that many vertically because they all need to basically, it's a for loop of 7, so for that's depth of depth, so at least this, and then I gotta move it up. Hey, yeah, you're right, Cletus. 21, 21, 21, 21. I didn't even catch that. Mm-hmm. So for the 1, I'll need to, so it used to be at 21, but now it's at another value. I need to also track the highest point when I serialize this. That's the problem. Okay, okay, I can do that. I can do that. So I can track how many rocks there were, how many rocks I stopped, and highest point in world. Hope this helps. Um, stuff, dot additional rocks, stuff dot additional rocks. Hopefully that's something for me to figure out when I get to this in the code right now. Great, we're here. So we were at 11 and we stopped 5. So now, how are we going to iterate on this? So I can do the difference from now, which is basically 11, 21, 10, right? So it'll be adding 10 to all of these positions. Okay, I can do this for depth of depths. Great. That'll be writing at current highest plus 10 minus this. So 21 plus 10 minus 1. I can do that. Okay, so world, no. World dot set. And then we'll say it to F for fake. So that is highest point in world plus stuff dot highest point in world minus depth. That's our row, and our column is I, which I don't have right now. But I do now. Okay, this is a good theory. Let's let her try. 110 am I looking for? Oh god. Now let's see. Oh, I need my real input. I don't even know what the original number was. But it should be fast. I can disable my patterning. 78. Well, that's not right. That ain't right at all. Oh, my goal's set to 50 still, ain't it? 78. That is correct then. Never mind. Let's bring it back. Set our goal back to 2022. And see if we get our correct output, which is, I think it was off by 1, 30, 67, or 8, or 9. Is the step not big enough for you? Where even is it? Here it is. Oh, nope, I am doing it, and I am saving it. Must be small. Okay, so it appears to be doing the thing, but not fast enough. Um, console log stuff. This is going to be a lot of output that I need to see. Just see how this progression actually helps us. Stuff, additional rocks. That's, oh, whoops, daisy. Whoopsie. Why ain't you running? Because I just changed the number. That would do it. I was probably going to break the answer. Yeah, 139. That's broken. Okay, back to our lovely goal of 50. Where's our thing? There we go. Back to 50. I have to put our jets back too. Yeah. Well, 68 or 78, that's actually correct for this jet alignment. Is this going to drop back? No, go back. Go back, go back. Let's go back to 110. 44. Okay. See what's up with you. Yep, so we got the pattern. We have all of this. Alright, 22. Oh, great. We didn't update highest points in world, did we? Of course we didn't. So that makes everything. Highest point in world equals stuff dot highest point in world. That might actually have done it. Let's give her another run. See if 44 changes. No. Okay. No, that wasn't it. So we stopped 5 rocks at the high point of 11. Should take us to 30 stuff. Let's just fast forward to here. Yeah, because I broke the lines. But looking at the world, where's our world? There we go. Lots of entries. We made it all the way to 20. $32. That don't seem right. I did the math. It was supposed to be 31. Okay, let's take a look at our lovely. Oh, I can't tell if actually. Okay, I didn't go inside. I see. Don't need that information. There we go. Yep, so we're at 22, and we need to add, not set, right? Yeah, because this is setting us back to 11. So plus equal another tweak. Still 44. Dang nabbit. Okay, if I disable all this, it's not gonna. And false. So you have to stop doing that. Just making sure it's not actually 44. It's not. It's 110. Okay. Another refresh. See what went wrong. Okay, so we are here. Let's at least go one forward. We don't need to be there. Great, yeah, so we have highest points in world, so we should be going to 33. And all of this should be updating accordingly. Yep, so where's our new position here? What's that about? 32. It's not how it worked on my math. So if I'm at, where am I? 22 plus 11. That's 33. Then it's 33 minus the 1 depth. This is 32. So why is it not going up at all? Yeah, so we're like setting up high coordinates, are we not? Let's zoom ahead to that. Yeah, and the new highest point in the world becomes 33. Right, so we're going up. And this calculation does not say we go up that much. Yep, new highest point, 37, 40. Wow, it's really freaking slow. And we finally find the highest point in the world is actually 44. Yeah, it's not doing what we want it to. Maybe we drop the else. Maybe this incremental pattern is not what we wanted. Here at the big run real quick. Nope. Oh, okay. Oh, that didn't help. 44. So I'm saying we're going by up by this many, and then we're supposed to be adding this much to the world. But we're not. Oh, it's too many? No, we are, but it's not enough. Dang. Well, this might be first one of the year that I think I'm gonna give up on because I do not see it, and unfortunately, do got real life tomorrow. Check in. Oh, GC. Run the entire input 3 times to confirm this cycle. Well, I'm faking my own cycle. Run 2 times number of shapes 10 times. I mean, I faked my own cycle and I still can't emulate it. Yeah, so this is just me not being able to replicate, to actually do the fast forwarding as we should be fast forwarding. Yeah, because like we're saving 3 pieces of information, the depths, the JI, and the RI. If we're on these two, that means, is there anything down here? No, there's nothing down here. That means we are already on the same JI, don't change, that don't change, and the depths also should not change. Yeah, that's gonna be a wrap for me. I'll try, and maybe if I do solve it, I'll solve it. If I don't solve it tomorrow, then I guess we'll be doing that. Try and solve it next stream. But yeah, again, appreciate y'all coming by. This is a tough one, but I do got to wake up tomorrow, so can't spin forever, unfortunately. I do think this is the solution. I mean, this has to be the solution. I just can't figure it out. This is the pattern, not the solution. But yeah, again, thanks for coming on by, folks. And I will catch you up to the solution next time. Yeah, I think I'd already caught you up to this one, which was the basically mapping. It was the last one. So yeah, for those who wonder like what happened after the last one, it was as I expected. Add a second argument for the elephant, caching, and then do the other stuff for the exact as the elephant. So there was nothing new there, so I didn't really touch on it. But for this one, yeah, I'll definitely try to go over it tomorrow. I guess it's tonight, but tomorrow, folks. Again, with that, I will see you next time. Toodaloo.